This is the GMKtec NucBox M6 Mini PC powered by the AMD Ryzen 5 6600H CPU. Now when I see mini PCs these days, it's difficult to find ones that stand out. And there's a lot that stood out to me in this unassuming $300 little PC, which I will detail here in a second. Full disclosure, GMKtec did provide the sample to me free of charge, so many thanks to GMKtec. But not to worry, I will definitely give you my honest and unbiased opinion. The version of the M6 I received came with a 1TB SSD and 32GB of RAM, which runs about $359 on Amazon. But the base model costs about $299 with 16GB of RAM and 500GB SSD. Or you can actually get a bare bones on the GMKtec website without RAM, SSD, or Windows for just $229. So what is it that caught my attention about this little PC? First, it has an AMD Ryzen 5 6600H CPU with 6 cores, 12 threads, 4.5 GHz with a 45-watt TDP built on a 6nm TSMC process. So it's a pretty powerful CPU. The CPU is coupled with an integrated AMD Radeon 660M GPU that claims to rival that of a NVIDIA GTX 1050. Like any other IGP, it makes use of system RAM as video RAM. By default, the VRAM was set to 3 GB, but you can adjust it anywhere from 512 MB up to 8 GB within the BIOS, which is useful for games that are hungry for VRAM, regardless of the performance of the GPU. One additional notable aspect is that it has a fully featured USB 4 Type-C port. No, it's not Thunderbolt, as I believe AMD can't or won't certify the Thunderbolt name on their devices because it is an Intel thing. But it does support 40 gigabit transfer speeds. It can also provide DisplayPort out up to 4K 60 Hz, and then also can act as a power supply for the device itself, so you can power it through that Type-C port apparently. It does have a separate power in the back, I'll show you that in a second. And it also can provide up to 15 watts out of that port too, according to their specs. Alright, now let's take a look at the rest of the device and the ports. You can see here is obviously the power button, a 3.5mm headset jack. Here is the USB 4 Type-C jack. And you've got two Type-A ports here that are USB 3.2 10 gigabit. Then over on the back, you can see here we have two more Type-A ports. One is a USB 2, this is a USB 3.2 10 gigabit. You've got a full-size display port and full-size HDMI port. Both support 4K 60, which I have validated. And then you've got two 2.5 gigabit Realtek Ethernet jacks here. And then there's your DC in barrel connector. And then you've got a Kensington lock over here. And you can see here the cooling fins for the thermal solution of the CPU. Now the device itself is all plastic, except for on the sides here, these grates, this cooling grates here are metal, both sides. And then on the bottom, you've got a little bit more cooling holes there too. And you've got a couple of mounting brackets here, mounting points, and this does come with a bracket so you can mount it to a wall, the back of a monitor, whatever. While the device itself came with a 120 watt 19 volt power brick with a barrel connector that connects to the back of the PC, I did confirm that you can actually power the PC through the USB 4 Type-C port. So now let me stress the system a little bit with Cinebench. And you can see here it's drawing about 78 to 79 watts of power while running Cinebench, so it's able to get power through that USB port. Here I have USB-C to DisplayPort, and so that USB-C port does support DisplayPort out, and you can see here we also have 4K resolution, and we go over to Advanced Display. You can see here we've got the 4K 60 Hz with an option for 30 or 60 Hz. And I also benchmarked the port using a USB 4 to M.2 adapter, albeit limited to PCIe 3.0 X4 speeds, but it was still able to achieve about 3200 megabytes per second read performance. I also took the time to validate the rest of the ports on the device, and everything seemed to operate as it should. Both of the 2.5 gigabit Ethernet ports were operating at 2.5 gigabit speeds. The three USB 3.2 ports transferred data at roughly 10 gigabit speed, and it managed to power an external SSD just fine out of the USB A and C ports. Now that's unlike the tiny GMKtec G5 that I reviewed previously that would drop connection periodically. Now I was only able to test the Wi-Fi 6E card at Wi-Fi 6 speeds with the router that I had available, but I was able to achieve about 80 to 100 megabyte per second transfer in close proximity and line of sight to the router. Both the HDMI and DisplayPort connectors provided support for 4K 60 without an issue as well. This device came pre-installed with Windows 11 Pro, and I had no issues whatsoever booting into Windows. I did not connect a network cable prior to initial boot up, and it didn't even nag me to connect to the internet to create a Microsoft account. I was able to create a local account right away. Now once in Windows, there weren't any additional programs installed, there were no devices with missing drivers, and Windows was pre-activated. I completed a full virus, malware, and rootkit scan, and it came back clean. Then I also decided to attempt a clean Windows installation using the Microsoft Windows USB creation tool. Once Windows was installed, thankfully there was at least a generic driver installed for the Ethernet adapter so I could run through the gamut of updates over the internet. When that completed, there were still several devices that didn't have drivers though, so heading over to GMKtec website, they provided downloadable drivers. Go to More Links, Support, Firmware Update. Then you can see here you can find the driver for every model, series mini PCs. Just go ahead and click that guy. Now in this case, make sure you're logged into your Google account, because if you are not logged into your Google account, it will say that quota has been exceeded and you're not able to download these drivers. So, and this is GMKtec M6. And there's the driver right there. So just download it and then you can extract it. Just to be safe, I ran the drivers through VirusTotal and they all came back clean. Once the drivers are downloaded and extracted, there is an install.bat file that you need to right-click and run as administrator to work properly, and all devices were detected and updated accordingly. Taking a quick look at the install.bat file, it just includes a simple Windows PnP util command. I also did a clean install of Ubuntu Linux using the file from Ubuntu's website, and everything was detected without any issues and worked perfectly fine. So here's a quick look at the BIOS. I'm not going to go through every feature, but I will kind of show you kind of what's in here. Just date and time, advanced Wacom LAN, trusted computing, TPM, ACPI. This is where you can set the memory for the GPU. And that's it. Now to take a look inside the device. Opening this little guy up can be a little bit tricky, but GMKtec offer a video on their YouTube channel showing you how to do it. You just have to pop up one corner of the top cover, then carefully pry around the perimeter to release all the clips. There are 4 Phillips head screws to remove that allows you to remove a plate which has a fan attached to it to cool the SSD and RAM compartment. Now with that plate removed, the M.2 slots and RAM are then easily accessible, with the stock SSD in the outermost slot. And if you remove that SSD, it exposes the Wi-Fi 6E module. Now you can see in here that the GMKtec M6 sports 2 DDR5 So-DIMM or laptop RAM slots. This particular model came with 2 sticks of 16GB ADATA RAM for 32GB total, running in dual channel at 4800 MHz. GMKtec claims that this device can support up to 96GB with dual 48GB So-DIMM DDR5 RAM sticks. And fortunately, I have a Crucial kit of 96GB, and I validated that it works fine within this M6. Another great feature is that this device has 2 PCIe 4.0 x4 M.2 NVMe slots. Now if you order the M6 with an SSD pre-installed from GMKtec, it will come with a PCIe 3.0 SSD and not a PCIe 4.0 one. It's clearly indicated in their marketing material, and both M.2 ports do support PCIe 4.0 x4 speeds with using an appropriate SSD. Now the stock SSD is an AirDisk brand, something I've never heard of before, but Crystal Diskmark benches it at about 2500 megabytes per second read and 1900 megabytes per second write. And running an actual file transfer test resulted in about the same performance. And by the end of the 120 gigabyte SSD file transfer test, temperatures peaked at 63 degrees Celsius. Now in order to validate that the PCIe 4.0 x4 slot is actually operating at PCIe 4.0 x4 speeds, or is at least detected as a PCIe 4.0 slot, I need to install a PCIe 4.0 x4 SSD. The fastest SSD I have currently is a 2TB WD Black SN770 PCIe 4.0 x4 M.2 NVMe SSD. Now this SSD has a maximum performance of about 5200 megabytes per second. So I'm not necessarily able to test it up to 8000 megabytes per second, but we can at least make sure that it performs as it should. So you can see from these results that the SN770 is actually performing as it should, and it is detected as a PCIe 4.0 x4 device. And just to validate that both slots could support PCIe 4.0 x4, I swapped the stock SSD and the WD Black in both M.2 slots, and Windows booted fine from either one. The WD Black was identified as running at PCIe 4.0 x4 and Crystal Disk Info on both slots, and it performed nearly identical regardless of which slot it was in, so there was no noticeable limitations in either of the M.2 SSD slots. Now one thing that I noticed, unfortunately, is when I moved the stock SSD to the inside slot, the 40mm fan that cools the SSD and RAM compartment interfered with the heatsink and I couldn't latch the lid down. You can't use it with the heatsink because it crashes into the fan. Once I removed the SSD heatsink, the lid secured just fine. Okay, now the heatsink is off. No issues getting this on. So if you install a second SSD, you'll need to install it without a heatsink or look for a very thin heatsink. Out of curiosity, I also removed the Wi-Fi module from the M.2 Type E slot, which was sitting underneath the outboard M.2 2280 NVMe slot. And then I replaced it with an M.2 E-key NVMe to PCIe M-key adapter with a Corsair MP600 Mini 1TB M.2 2230 30mm long form factor SSD. And it actually looks like there's enough room if you wanted to that you could also add a 42mm long M.2 SSD with such an adapter. Once installed, not only was the 2230 SSD detected, I was also able to boot Windows off of that SSD without an issue. Crystal Disk Info indicated that the device was a PCIe 4.0x1 slot, which has a maximum theoretical speed of about 2000 megabytes per second. The actual SSD performance in that slot was about 1700 megabytes per second. So at this point, I decided to load up this little PC with 3 M.2 SSDs, 2 2280s and the one 2230. I moved the stock SSD over to the inner M.2 slot after I removed the heatsink. I installed the WD Black SN770 M.2 2280 SSD above the 2230 Corsair SSD, and then I ran a full disk read test of the SN770 SSD using Hard Disk Sentinel to check for cooling performance of the bare SSDs. In HWInfo64, there are 3 SSD temperature readings for the SN770. The first one seems to match with the one shown in Crystal Disk Info. The other 2, I'm unsure of their accuracy or use, however. Once I started the test, I had to abort it halfway through. While the SN770 SSD temperature 1 was hot, at about 85 degrees Celsius, temperature 2 reached 115 degrees Celsius. Now I'm not sure if temperature 2 is a valid temperature or not though. Regardless, 85 Celsius is still a little too hot for my liking. So seeing if I could improve thermals, I got a hold of 1mm thick copper heat sinks for the M.2 SSDs, and it measured about 1.9mm total with a thermal pad. The thickness of the stock SSD heatsink with thermal pad is about 3.6mm, so it's about half the thickness. With the thin copper heat sinks installed, it allowed me to install the lid just fine. But looking more closely at the copper SSD heatsink with the lid installed, there's barely any gap between the fan and the inner M.2 SSD heatsink, likely blocking any airflow to the other SSDs. So I booted up, reran the tests, and the results really weren't that much different than without the thin heatsink. So then I propped up the edge of the plate with the fan to force air over the SSDs, and the results improved quite a bit actually. The SN770 temperature 1 when stressed with a full disk read test did not exceed 73 Celsius, and running a 120 gigabyte file transfer test, it didn't exceed 65 Celsius. So it seems that cooling is legitimately a concern here and could use some improvement. However, with just general use in doing file copies and OS operations, the SSDs really never exceeded 80 degrees Celsius. As far as CPU performance, I ran the Cinebench R23 benchmark, used Handbrake to encode a 4K 60 10-minute video to 1080p 30, and also zipped a folder with over 1,000 files and a few gigabytes in size, and I compared them against a couple other CPUs, the i3-10105 65W TDP, 4-core 8-thread, and an AMD Ryzen 5600U 15W TDP with 6 cores, 12 threads, and another mini PC, and here's those results. For general purpose desktop work, there were no apparent concerns. Streaming 4K videos through YouTube worked perfectly fine without any lag or frame drops. Now the few frame drops you see there are from when the video first started up and then I switched to full screen, but afterwards streamed without any problems. Of course, the biggest draw about this device, I think, is its gaming ability. I ran a number of gaming benchmarks and for the most part it managed most games at 1080p low settings well above 30 FPS with little to no frame drops. Now more demanding games like Cyberpunk 2077 and Helldivers 2, they were more enjoyable at 720p medium to high settings, and it was actually able to achieve a smooth 40 to 50 FPS. So here's some benchmark results comparing the GMKtec M6 to a 15W AMD 5600U with Radeon graphics, as well as a desktop 1050 Ti and a Radeon RX 6400. 3D Mark Time Spy score of 1802 with a graphics score of 1591. And then I ran Firestrike, which ended up with a 4675 score with a graphics score of 5023. And now here we have results of the GMKtec M6 represented by the purple against the three other GPUs that I showed you, the 1050 Ti in black, the Radeon RX 6400 in gray, and then the mini PC with the Radeon integrated graphics with the Ryzen 5600U CPU in white. Now I also benchmarked the GMKtec M6 against those three GPUs running at 1080p low settings against 10 different gaming benchmarks. Now the pink purple is the GMKtec M6, the green is the NVIDIA 1050 Ti, the blue is the AMD Radeon RX 6400, and the yellow represents that mini PC with the Ryzen 5600U CPU. Darker regions represent the 1% low FPS, and then the value up here that we're looking at is the average FPS throughout the benchmark. This line here represents a 30 FPS threshold, and so you can kind of get a feel for whether or not the game is more or less playable if anything is above that line. So clearly you can see that the GMKtec M6 really doesn't hold a candle to the 1050 Ti or RX 6400 in many of these benchmarks, but it's definitely well above the 30 FPS threshold line here. Now I also ran those 10 gaming benchmarks on the GMKtec M6 at different resolutions and details here. The red line represents the 30 FPS threshold, and the yellow represents 720p low settings, green represents 720p high settings, orange represents 1080p low, and blue represents 1080p high. So the GMKtec M6 is a pretty capable GPU. You can see here that it can actually run at 1080p low or high settings in many games, running well above 30 FPS threshold. And then if you bump down the resolution and detail, you can definitely get much higher frame rates if you desire that. Now regarding the cooling performance of the M6, there are two fans in the system. One for the RAM and SSD compartment that I already showed you, which is just a small 40 by 8mm thick fan, and one in the CPU compartment, which requires removal of the motherboard to gain access to it. With a 45-watt TDP CPU coupled with a powerful integrated Radeon 660M GPU, some extensive cooling is definitely needed. The fan does become noticeably more audible when the system is stressed, and it does an okay job keeping the CPU temps under control, although during some Cinebench testing, the CPU did hit 93 Celsius at one point, but the CPU maintained 4 GHz throughout the test and did not thermal throttle. And then also in Forza 4 benchmark, which I think is probably the more intense gaming benchmark there, it did not exceed 80 degrees Celsius throughout the test. As far as fan noise, here's the measurement using a decibel reader as well as my microphone within close proximity to the fan. Now when idle and with light use, the fan is barely audible, but as soon as you stress it, the fan noise is pretty apparent. However, it's more of a low-tone whoosh rather than any kind of high-pitched whine. And here's fan noise while running Cinebench. There's no ability to adjust the fan curve in the BIOS either, unfortunately, so that means the only real hope to decrease temperatures and fan noise is to change the thermal paste, but that unfortunately is a risky prospect. But being the nerd that I am, I disassembled the mini PC to get access to the CPU, 4 screws to remove the motherboard, 3 screws to remove the fan. So this tape has to come off of here. Oh, just like, there we go, simple. There we go. And then there's the fan, labeled as GMKtec Red Plus. And now to remove this monstrosity, I mean, that's a pretty aggressive heatsink there, something like you'd find in a laptop. And then there's 4 screws securing down the heatsink, 2 of which are under a thermal sticker joining the fan to the heatsink. And there we go. That's your cooling solution right there. You've got your base plate that goes down to the CPU, heat pipe, and then to the fins here. Looks like it's all copper. This might be aluminum or stainless, I don't know. So there's the die with the CPU and the GPU, and there's no markers or indicators on there at all. It's just one flat mirrored surface. So there's a close-up of the die, and you can see some text on there. Made in China, diffused in Taiwan, AMD up there. There's your heatsink all clean. It's like 15 millimeters thick. Heat pipes themselves are like 3 millimeters thick. So to replace the thermal paste, I'm going to use this SYY 157. This is a good performing thermal paste. It also doesn't require a high clamp force, so it's something good for like laptops or something like this, where you're not going to really be clamping down on the heatsink to the die, and so it should have good long-lasting thermal improvements. I then reassembled everything, crossing my fingers everything would actually work again. And it booted up just fine. I then ran a Cinebench R23 benchmark and Forza Horizon 4 benchmark, and the difference in temperatures, unfortunately, were not much improved. Benchmark scores were nearly identical too, so there really wasn't any benefit to changing the thermal paste that I could find. I used HWInfo64 to record some metrics of the CPU during the Cinebench R23 and the Forza 4 benchmarks before and after repaste. And here are those results, so we can take a more close look and see how it improved performance, if at all. Now over on the left here, we've got the scale, which represents CPU usage percentage in orange, the CPU temp in degrees Celsius in green, and the CPU power in watts in yellow. And the scale over on the right represents the core clocks in megahertz in blue. So really what we want to take a look at is the CPU temp here in green. Now the solid line represents before the repaste, and the dotted line represents after the repaste. So you can see the solid line here in temperatures here gets up to around 90 or so degrees Celsius and then stays there throughout the remainder of the test. After the repaste, you can see here it kind of goes up, and it kind of is cooler in the beginning, but then it gradually kind of ramps up here to approaching that 92 degrees Celsius temperature that we had previously. So it improved it maybe a little bit, but not by a whole lot. Then if we look at all the other metrics here, like CPU usage, CPU power, and core clocks, there really was not any significant difference there either. Now if we take a look at the Forza 4 benchmark, we had a similar result. You can see the solid green line here is the temperature before repaste, and then the dotted green line is after the repaste, and the temperatures ran maybe a degree or two cooler, but nothing of substance. And then the other performance metrics were pretty much the same, so there was really no improvement there either. So it seems changing the thermal paste on the system really didn't help matters all that much. The overall power consumption of this device while idle ran about 11 watts. With light use, browsing, and YouTube viewing, it was around 20 watts average consumption. Now under load, with like Cinebench and some gaming, it typically hovered between 75 to 80 watt draw from the wall. The touch surface temperature of the machine was only about 36 Celsius at the top, and 46 to 47 Celsius at points in the rear. There was nothing uncomfortable to the touch on the device anywhere, or risk of burning your skin or melting something sitting behind the exhaust. So overall, the GMKtec NucBox M6 is a great bargain gaming machine with a lot of features, especially with the support for dual M.2 NVMe PCIe 4.0 X4 slots, and a Wi-Fi slot that can be modified to work as an additional SSD slot. I can see this working as a basic compact NAS unit even. The full-featured USB 4 port, dual 2.5 gigabit Ethernet ports, 3 10 gigabit USB 3.2 ports, and the 4K 60 HDMI and DisplayPort outputs round out the package nicely. Now it's definitely more than adequate as a general purpose computer, only sipping about 11 watts while idle, running around 20 watts with light use. The GMKtec M6 can run most games at 720p high or 1080p low settings, and even demanding games like Cyberpunk 2077 and Helldivers 2 run well above 30 FPS at 720p low or even medium settings, all while consuming about 70 to 75 watts. If there's anything that I think that needs improvement, it's the cooling system. It's not awful, but running at 80 degrees Celsius during gaming and 90C plus with 100% CPU utilization accompanied by a loud fan is far from ideal. Furthermore, the inability to use anything but a 1mm copper heatsink on the innermost M.2 SSD slot is a bit concerning too. However, with general use, and if you don't stress the SSDs for an extended period, they actually manage to stay reasonably cool under 80 degrees Celsius. Despite those couple of issues, I personally think it's a great value for the money, but I'll leave that decision up to you. Now thanks for watching and listening, and until next time, I'll talk to you later.